We'll start with the most common security threat in Windows systems, and we'll see how this problem is solved in Linux. It's often said that the greatest security threat for Windows users, computer virus and malicious software, is the least threat for Linux systems. This is quite accurate. An average Linux desktop environment user doesn't have any antivirus programs. Such applications exist, but they're not required if you follow basic security rules. Existing antivirus programs, such as ClamAV and F-Secure, are used mainly for servers that work with computers running on Windows systems. This category includes email servers, FTP servers, or file servers. They aren't used to protect the server, but in order to identify and eliminate virus threats in exchanges between Windows users. Common viruses that spread through USB devices in the form of hidden files are virtually harmless for Linux system. First, because they won't run in Linux, and second, because applications they try to impersonate don't exist in the system. And even if they did, thanks to Linux default security settings, the original application, rather than the virus, would be opened anyway. Sometimes you're able to appreciate how much malicious software you have on your flash drive only when you connect it to Linux. This is due to the fact that hidden files you don't normally see in Windows are displayed by default in Linux. So actually, the easiest and safest way to scan and clean an infected USB stick, for example, is to connect it to a computer running on Linux, and deleting potentially hazardous file types. Why aren't there any viruses for Linux? This is largely thanks to privilege separation. Even if a virus infects an account of a regular user, it won't give him access to the system as a whole. Of course, this does not mean that the virus is effectively harmless. If a virus manages to infect the part of the system the user is currently working on, it will probably try to infect the user's files, damage some data, and transfer itself to the account of another regular user. It will not, however, pose a threat to the system as a whole. The system will be stable and saved from the threat. In order to remove this virus completely, you just need to delete infected files from the user's home directory. Any program or external library used by this program will be granted only certain privileges required to perform specific tasks in accordance with the privileges granted to the user. If an ordinary user opens a program that uses some system libraries, the only user that can modify these libraries is the administrator. The administrator has a completely different set of privileges than the current user, who can execute only clearly specified operations. Due to the fact that the regular user cannot modify system libraries, the virus tries to execute itself from the level of the user's account, and will not have the privileges enabling him to modify these libraries either. An application typically does not have permissions to modify its own files. It can only save some data in the current user's home directory. It's a completely different situation than in Windows, where system libraries usually run with the administrative privileges or system privileges. Here, the risk that a virus will infect the whole system is much higher. Unfortunately, most Windows users work on accounts with administrator privileges. This is because many operations cannot be performed from the level of an ordinary user. Some games require administrator privileges, or else they won't run at all. Development applications such as Visual Studio and other programming tools or databases must run with administrator privileges too. In Linux, the situation is completely different. Here, every application can be run from the level of an ordinary user. You can also manage a web server with basic user privileges. In Windows, this is almost impossible. In Linux, to allow a virus to infect the whole system, a user would have to open an infected program from the root account. Also, it's not possible for a code to auto-execute. Therefore, you shouldn't worry about viruses placed in email attachments. If you open an email client and there's a message with an attachment containing malicious code, it won't be able to infect your system unless you download the attachment. It's not possible for any application to be executed directly from the email client. And even if you saved such a malicious program on your computer, it would still need to be granted appropriate executable permissions. No program has executable permissions by default. So the user would have to open the malicious program manually. And they would need to do it from the root level, because only then the virus would have any chance to infect the rest of the system. As you can see, the possibility of a virus infecting the whole system is very limited because of privilege separation. This does not mean, on the other hand, that it's entirely impossible, but you have to follow all the steps we've just described. However, the vast majority of users will not be able to grant executable permissions, and the virus won't spread. When you have an image file and an executable file, in Linux the image file will be better supported, and there's no possibility of an unauthorized use of the code. You should be aware that Windows is a very uniform environment. Windows Vista differs slightly from Windows 7, but the principles the systems are based on are the same. If Windows Vista is vulnerable to certain threats, so is Windows 7, and other versions of the system likewise. Linux systems are much more diverse. Each distribution introduces some adjustments to the tools. Each distribution offers different default sets of tools, security policy, and settings. In some distributions, the administrator privileges are even disabled. Tasks requiring administrator privileges are performed using the command sudo. Each distribution has a different file architecture and different system of packages, so the spread of a computer virus on Linux systems is hampered by the diversity of the system. The virus must be a small application designed to attack a specific hardware platform. Therefore, a virus won't be able to spread so easily as it does on computers running under Windows systems. Each Windows user has the same software platform. The bigger the target group, the easier it is to write a virus. Please note, however, that from the perspective of an individual Linux user, the virus can still do a lot of damage. Therefore, don't put your system's security to test. If you visit unsafe websites or open attachments from unknown sources, sooner or later something bad will happen. Viruses are not the only threats to your system, and the fact that a virus won't be able to move beyond your home directory doesn't mean that it's not able to destroy your files. You need to be careful, and this is enough. When you use Windows, being careful and responsible is not enough. If you don't have antivirus software, your system is vulnerable. Not so in Linux. If you're careful and don't open files from unknown sources, nothing bad can happen. Throughout the course, I'll often repeat this: never work on the administrator account. The root user on Linux has much more permissions and privileges than the administrator in Windows. If an administrator requests an action, Linux will always execute it. You should pay special attention to this.